Generating random images with a JIT compiler. So I'm showing you a JIT compiler that I've made with which you can create completely random images based on a mathematical formula as seen in this one here. So I've created a program that specifies that the image shall be interesting and the tree can be simplified, and then with all of that information, we can JIT compile the tree to make it run faster and on the native hardware. To show this is a completely randomly generated image, and if you really like to, you can regenerate the image by entering the same seed as seen here. Then this should regenerate the same image as seen. This is the same image. And then you can set the size to 800 times 800 pixels. Then it will generate a bigger version of that image fast. And to show that it works, depending on the optimization level, I run it with time. You see the same picture. With the JIT version, it takes around 0.66 seconds. And without the JIT, it takes 0.7 seconds. Yes, it's a bit slower, but with bigger programs and bigger output image sizes, this will have a great impact. But if you think, if I remove some other stuff like that it shall be interesting and the seed also, then it might end up like this, a completely gray square. And the -v option is verbose, so printing all of this extra information. With -h you can get a help menu, and if you look here, I have many files. An helper function file, the part where I have the JIT, the main program, and downloaded library, and another helper file. And if we look at this JIT file, you can see JIT stuff, but also a lot of x86-64 assembly because I don't have an ARM computer and I don't like using Windows. And also, it's not really good because in the compile tree to make the JIT program, I also have x86-64 instructions, which shouldn't be here because it's not architecture independent. Yeah. And what's also here you can see all of the functions that are available in my program, in the random art generator. First of all, a raw number, then xy. This can be used as a three-dimensional vector or in color. This is the sign, this is square root function. These take 2 operands, these only 1. All of these you should know how they work. The dot and the cross product are a bit more interesting. This will return all of the colors as RGB, the same value, and cross product. And in the main function, you can see that I have RGB as floats, in the processing, but when writing this with STB, I use RGBA in an 8 uint8 fashion. Here I do some argument passing and then here generate the JIT code, here printing the verbose stuff, and then going through every pixel on the image, generating the color, and placing it at that point. To note is in the center of the I use a different picture. So in the center of the image, that's 0, 0. So at position 0, 0, this is here. This is position -1, -1, I think. So you can think from left to right, it's from -1 to +1. But because of the size, because you can change the size, this might be from -2 to +2. And the color output goes from -1 to +1 also, to make it more smooth and such. But the values are also cropped back to, not cropped, just forced to be in that format. If you have +2 of a color of +2, then that might be 0, which can happen. Yeah.